All right. What's up, human beings? I am John Haddad. This is This Week in Cassandra. With us today, we've got Luke Tillman, we've got Patrick McFadden, both of Data Stacks, and we have Gianluca Morello from Sysdig. Right? Did I do okay with the name?
Yeah.
All right, good. So last week we talked a little bit about the Sysdig blog post that you wrote on Planet Cassandra. So this would be a cool opportunity to go into detail with that for the second half. Exciting. So we got a couple JIRAs moving here that I kind of wanted to take a look at before we approach the Sysdig topic. The first one that I wanted to touch on is this DTCS JIRA. You can find the link for this in the This Week in Cassandra blog post. But there's a DTCS alternative that's been proposed effectively. So when you're dealing with lots of time series data in Cassandra, you've had the compaction process, and if you have huge partitions that start growing and you're using something like size-tiered compaction, you can end up with kind of unpredictable performance as a result of compaction. So it can get a little bit hairy. And then there's an alternative. There's a compaction strategy called date-tiered compaction that's specifically meant to handle time series workloads. And there's an alternative called time window compaction, which was written by Jeff Jersa and submitted, and he's trying to get it basically pushed into mainline. So that's kind of what we're looking at there.
So the controversy, or the reason why this is a JIRA ticket, so maybe to back up just a little bit and give some history, is that when date tier compaction strategy kind of first came out, there were some issues with it, which they're linked to actually. If you go and look at this JIRA ticket, there were some performance problems, and then there were some concerns about maybe usability. Would that be fair to say? Maybe like that that it was hard to configure, hard to use, and so time window compaction kind of came out of users' frustration. Like, yes, they wanted something for working with time series data, but they wanted something maybe that was easier to configure. And then the way I read through some of this is that they wanted to get rid of the tiering part as well. That's part of the compaction strategy. And so now we've kind of got this ticket where they're trying to decide, can we merge time window compaction strategy in? Is it one or the other? Like, do we have to pick between the two? Are users going to be confused if there's two sort of time series compaction strategies? Mm-hmm. And I think probably the reason we want to highlight this is maybe not necessarily to take a side one way or the other. Maybe I don't know, John. You like taking sides, so maybe you have an opinion. I can't say that I do, but to get users that are out there, like if anybody's out there listening to this and they're doing time series data and maybe they're using one of these two compaction strategies, to say, hey, go take a look at this ticket. The more information we have from you out there in the community on how you're using things, the better off this decision is going to come out, basically.
Yeah, we definitely need. This is a great case of like community feedback being like absolutely necessary to make the right decision on this, right? Like if everybody in the world is using date-tiered compaction and successfully, then merging in another thing that does sort of the same thing but a simplified version may not be appropriate. Gianluca, what compaction strategies are you guys using over there?
So at the moment we're using the level tier compaction. I admit I have been kind of interested into experimenting with something newer and more advanced. So I admit what you just mentioned has been in my to-do list for quite a while now. So yeah.
Do you guys store time series data at all at Sysdig?
Yeah. We essentially the main use case for our biggest Cassandra cluster is actually storing big time series data. They are not time series in the typical way you would imagine. So we just don't store numbers. Let's just say we store time series of large binary blobs. So for us, a time series is a series of big binary data at periodic time interval across time, and we have different, let's say, timelines that goes from data that has a few second granularity to data that has a few minutes to a few hour granularity. So definitely a time series. So that's why these compactions might actually be useful. But we've been quite happy with the LCS.
Mm-hmm. And I'm assuming that you're running everything on solid state drives.
Yeah. We are running everything on AWS. At the moment, we are on a C3.4 XL, so very expensive but very fast SSD. Yeah, we are thinking about experimenting also with the i2 to get a larger, essentially a more dense cluster, and reduce the cost per gigabyte. But so far with the C3 and SSD has been good.
Okay, very cool. So how big of a cluster are you guys working with?
So we have essentially different clusters. We have essentially several applications, and we have clusters of all sizes. I wouldn't say that we are overly big. I think our biggest cluster is in the order of 30 nodes or something like that. But we constantly experiment, with fake data, traffic replayers, and so we come up with pretty articulated test scenarios. For example, just a few days ago, while I was troubleshooting while I was essentially doing the troubleshooting that then eventually led to the blog post that appeared last week, I was trying with a very cool scenario where I had a cluster of 60 Cassandra nodes, all in Docker containers on a single huge M instance on AWS. So we had this cool script that would just spin up from nothing a Cassandra cluster, and it was super cool. With just one instance, you go and log into a container and do node tool status, and you see 60 instances, and you can effectively measure all the cluster activity with a single set of tool without having to log into each server if they were separate instances. So yeah, we definitely experiment with quite a lot of those things.
Cool, very nice. The next Jira that I wanted to take a look at is adding support for the group by statement group by clause to select statements, and that's 10.707, again linked to in the blog post. I am pretty excited about this. There's like so here. I really enjoy the constant features that are coming out as the result of TikTok. Like every 2 months, it's like Christmas, and I basically get to play with new stuff constantly. So this is really cool. I think, Luke, you and I have done like 20, 30 talks together, and people, how many times do people say what's the deal with aggregations? Asking. Yeah. It's just constant. I think having even basic support for aggregations in Cassandra is a huge win.
And this looks like, is it aggregations within a partition?
So it's, oh god, there's a lot of.
To me, that's what would make sense, performance-wise, because aggregations across partitions introduces a whole other thing.
Yeah, I don't think that we're looking at across partitions. I believe that the point here is actually no. I think it may be because the original description says it should be possible to group either at the partition level or at the clustering column level. So there's a lot of information in here. I mean, this issue's been going back for 4 months now. So there's
our when people ask about aggregations at Cassandra days and stuff, our answer was typically Spark, or you do it in your application, kind of answer. So yeah, you're right. This is definitely an exciting feature.
Yeah, I think it is across. It may be across partitions, but I need to dig deeper into this to be certain. But yeah, like this is just, it's so commonly asked for, and it makes a lot of sense. Like I agree. Like even if the feature supports doing it across partitions, in general, it's probably a horrible idea. It's kind of like we have user-defined aggregations, right? And we're like, don't ever do it across partitions because it's just crazy. Like you bring 100 million rows back to the core data and then try and aggregate that. It's like not cool. Not cool. So I think in general, it's one of those like, you can maybe, but don't. Even if you can, don't do it. And better, you're definitely better off having a good, solid data model where you can avoid some of the craziness anyway. And I think a lot of the aggregations that we're going to see are in time series data. That's where it's like really interesting. So maybe
follow along for progress.
Yes, that's a good time. So I think the thing that we wanted to talk about with you, Gianluca, about your blog post last week, hoping you could kind of elaborate a little bit on your experiences with Cassandra and how are you using Sysdig. And I mean, when I say using, I should really say writing. So I think you mentioned that you wrote the first line of code on Sysdig earlier, which is pretty awesome. Why don't you tell us a little bit about Sysdig and kind of why you started working with it and how it helped you with Cassandra?
Yeah, definitely. So essentially, at Sysdig, we are a group of pretty serious low-level system users. So we have always been big troubleshooting nerds. So essentially, when other people usually are bothered by the fact that they need to do some troubleshooting, I get quite excited. I say, wow, now we have a system problem that we need to address. And so while the ecosystem for troubleshooting is essentially very, very, very good in the open source world, I mean, in Linux there are some extremely killer tools, simple one, more advanced ones such as perf or tools like that. We thought that at Sysdig essentially we could do something similar that will make essentially troubleshooting much, much easier, and that's what we try to achieve with Sysdig. So essentially Sysdig can be thought of as sort of replacement and enhancement to all the traditional troubleshooting tools. So essentially, I like to think of Sysdig as a TCP dump, not for your network, but really for your entire system with some nice additions. And it turns out then also that Sysdig has a huge advantage when you start talking about containers, because when you start talking about containers, now you have all your processes, such as Cassandra, that live in a completely isolated environment. And if you're going to use the traditional troubleshooting tools to essentially make live on issues, you're going to face significant challenges. For example, let's be practical. In the example that I mentioned before, that I have a Cassandra cluster running entirely on Docker on a machine, which again was for testing purposes, but can actually really happen. I mean, we know of people, some of our customers run Cassandra cluster within Kubernetes, so all inside Docker containers. If you want to measure, for example, let's say the internode traffic activity, you're not going to be able to easily do this with netstat or iftop, mostly because each Cassandra instance will live in its own network namespace. So each Cassandra instance, from the point of view of the system where you're running your netstat, is almost a different network machine, because has a completely different network stack. So if you do netstat, you're not going to be able to see, for example, the connection that your Cassandra hosts are doing among themselves in the cluster. And this, for example, is something that is extremely interested in monitoring, because following up to my blog post, I didn't have the time to write it, but what we found out essentially is that not only by doing that optimization we were able to get a much lower response time, but we were also able to massively optimize the network traffic. So the measurement were essentially this. I took my Cassandra cluster in a Docker container, and I started running my benchmark. And then with Sysdig, since essentially it was the only tool with which I could efficiently see the network traffic across containers, I started monitoring what was the network traffic on port 9042, which is essentially the client port where you connect with your Python or Java code and essentially read or write, send read or write queries. And I measured the traffic on port 9042. Then I measured the traffic on port 7000, which is the internode Cassandra port, so where nodes exchange essentially all the information about replication, or where the coordinator will actually make the data flowing across all the replicas that can serve a specific query. And so by measuring this, I was quite puzzled that in the first iteration, we saw that the internode activity on port 7000 was 20 times more than the traffic on port 9042, which sounded very crazy. Why? Because this was affecting our AWS bill in a massive way. Like, the data traffic on AWS is very expensive. So we started doing the math, and we started saying, wait, we do all our queries, all our read queries at consistency quorum, right? So in the very worst case, assuming we had to read data from all the 3 replicas, in the very extreme case, I will never expect an internode traffic which is more than 3 to 4 times the amount of traffic on port 9042. Whereas here I was having 20 times, so massive. And this all came out of us essentially after doing troubleshooting. It all came out to the fact that due to the way we design our schema, the coordinator, when he was asking essentially to the replicas, give me the data for this specific query, was sending on the network all the columns of the table that I didn't really need, I didn't really ask for. So this was essentially the same problem that I explained in my blog post, but brought to the network level. And so by doing the optimization that we were able essentially to spot by refactoring the schema, we were able essentially to bring the internode traffic back to now it's, I believe it's between about 4 times the traffic on port 9042, which is incredible, because now all the CPU on our Cassandra nodes went down, and most important, our AWS bill for our Cassandra cluster really shrank in almost half. So this was really a massive success, and so probably for very expert Cassandra users, this thing might seem like straightforward, but if you don't think yourself as an expert Cassandra user, then start measuring things like the network traffic that you see, and start doing some system troubleshooting also that can help you essentially shed a lot of light into your problem. So this is what we did, and this is essentially the typical use case that you would use for Sysdig in containers. So yeah.
Cool. This is one of those things that kind of reminds me of when you start to explain it, it makes a ton of sense. Like, you should absolutely know what's going on in your network.
Yeah.
But it's one of those things that's also easily overlooked. And I think a lot of people will kind of view stuff like this as a premature optimization. They'll be like, they'll quote Donald Knuth and be like, premature optimization, we don't need to do that. But I think it kind of falls into that same category as like understanding how JVM tuning works. Like about 3 years ago, I had an application running in production with my previous company, and we were seeing some pretty bad performance problems. And when we finally dug in and like really tried to like understand what was happening in the JVM, we were able to bring just from changing the heap size and the new gen, we were able to make our queries go from about 25 to 30 milliseconds down to about 3. And to go 10 times faster is definitely not a premature optimization. It's an absolutely ludicrous improvement. And I think what you're talking about is in that same category. It's something that a lot of people will just kind of assume that, maybe looking at this is a waste of time, or looking at this, we're not going to see a big improvement. But to be this thorough is so important, because you can really get some huge wins. And I imagine that, like, that this is one of those things where, the network traffic is going to impact, because there's lots more data coming in onto your coordinator. It's going to affect your GC times. So between like JVM tuning and understanding your schema, you can end up with like crazy performance variations. So it's one of those things where it's like, people if you don't take the time to understand what's going on in your cluster, you could run into really bad results. And it is complex. It's a distributed system. It's not something that's easy to get right away, and it takes a long time to get good at it. But this is absolutely how you get good at it.
I think another thing that's kind of cool, though, is like we always preach the importance of schema, right? I mean, like every event we ever do, we always talk about data modeling, schema, getting your schema right, that. And I'd say, having talked to people that are out in the field, even as often as we are, working directly with customers, they say like 90% of the problems. I think I was talking to Ben Bromhead at Instacluster the other day, and he said 90% of the problems we see are still schema related. People getting their schema wrong. But it's pretty cool, like that. You have a schema problem like this, and then you end up using system tools, like Sysdig, to actually then kind of figure out, oh yeah, this is something that we could solve with a schema change. So it's kind of funny how it manifests. Schema problems manifest themselves as stuff like like network problems or I/O problems, that kind of thing.
Yep. Yeah, I think it's awesome. So, all right, I think our time is pretty much wrapping up here. So I think we covered all the things we wanted to talk about, right?
Yeah, I think so.
Okay, cool. Gianluca, thank you very much. Anything you want to say before you peace out?
Go install Sysdig now.
Are you guys hiring? We always let people plug if they're hiring.
Yeah, of course. Yeah.
He's like, oh yeah, we're hiring. But not if you don't use Sysdig.
No, of course. You need to come very prepared.
Yeah, you better have Sysdig on your resume. Awesome. All right. Well, I think that Luke, anything?
No, nothing.
Oh, one last thing. Call for papers. Cassandra Summit CFP is open. We have a link at the bottom of the blog post for This Week in Cassandra. So definitely check that out. Submit some talks. There's going to be a lot of them. The review process is crazy. But yeah, we love good talks at this thing, and the Cassandra Summit is always a good time. All right, let's wrap this one up. Thank you very much for coming on, and I think we're good to go.